All right. So today we're going to continue with chapter 2. So chapter 2, we have done with a linear motion, the graph, and then we have seen what is a vertical linear motion and then what is a horizontal linear motion. So today we're going to look at projectile motions. Now the main difference between projectile motions and a vertical and a linear motion, vertical and horizontal linear motion, is that vertical and horizontal linear motions, they are one-dimensional motions. Means that you don't have to resolve it. You don't have to think whether the object is moving along x component or y component because you have just one component. But when it comes to a projectile motions, then you have to be careful because projectile motion is a two-dimensional motion, in which it means the object, it might move in between x and y component, where you have to resolve them into x component and y component before you find the values that you want. So today we're going to discuss 5 questions. So let's see. First questions. So questions 1. Okay, exercise 4, questions 1. The car drives straight off the edge of a cliff that is 57 meter high. And then the investigator at the scene of an accident notes that the point of impact is 130 meters from the base of the cliff. How fast was the car traveling when it went over the cliff? So first thing, let us label the diagram first. Now it tells us the height of the cliff is 57 meter. Okay, and then the locations where it hits, okay, it hits the ground at 130 meter from the base of the cliff. And what else do we have now? The question is asking for the speed, how fast, okay, was the car traveling when it went over the cliff. So it wants the initial velocity. All right. So if you look at this diagram, this is examples of horizontal projectile motion. Okay, horizontal projectile motion. Now, when we talk about horizontal projectile motion, okay, the object, the initial velocity of the object is going to the right hand side. So this is your u. Okay, this is your u. And if you look at the diagram, now the velocity, it lies on the x component. Therefore, we can also say the initial velocity is equals to ux. Now, how do I know that this is the directions of the velocity? Well, if you remember, what did I tell you last week? So now you have a curve, let's say. You want to find the directions of motion at certain point. Now, usually we look at the path, right? But the proper way when it comes to vector, we use the tangents of the curve. So what does it mean by tangent? Now, let's say I want to find the direction at this position. So I draw a straight line that is perpendicular to the radius. So this is radius. So the line that is perpendicular to the radius, this one we say is its tangent. Okay, it is tangent to the circle. So in this case, my object is moving at this point, the directions of the motion is going to the right. Then how about here? If I want to determine the directions of object at this position. So I'm going to draw another straight line that form 90 degree. Okay, that form 90 degree with the radius. And this line is that it represents the directions of the motion at this point, at point B. Okay, just now point A, now point B. What if I want to determine the direction at point C then? So this is point C. So again, you draw another straight line that will form 90 degree, okay, with a radius, so 90 degree. So this is the directions of motion. Okay, it represents directions of motions. So when the object is located at this initial position, okay, let's say I'm going to label it as an initial. So if your object is located at these initial positions, the tangent of the curve of this projectile motion is going to the right, is heading to the right. All right, it's just like your circle at this position A. What is the directions of the car? So the directions of the car is going to the right. Okay, so that is exactly what happens in our diagram. So at the initial position, my resultant velocity is equals to ux. Okay, so what does it mean? It means uy is equals to 0. because the resultant is lying on the x component. So of course, if all of the velocity, if the resultant is already lying on the x component, there's no value along the y component, right? So let us complete the table. Okay, now this table is very important, but it is not compulsory in your exam. All right, it just helps you to keeps your data in a more tidy form. Okay, to make it easier to see, to check, to find. Okay, it helps you how to organize your data, your informations. So let us complete the table now. Whenever you form this table, you must have 4 vector with a 1 scalar quantity. So which 4 vectors? So these 4, they are vector. Now, why is it important to know which one is vector, which one is a scalar quantity? Vector means that you have to take into considerations their direction. So the informations along x component can only be used to find the informations along the x component. You cannot use them to find the informations on the y component. Whereas the informations on the y component, along the y component, can only be used to find the informations along y component. You cannot use it for x component. Okay, so that is the idea. Then one last one is the scalar quantity. Okay, one last one is the scalar quantity, which is the time. So time is a scalar quantity. Now, what does it mean then? So why do we need to know whether it's a vector or it's a scalar? Vector, you cannot use them for different component, for the other component. But when it comes to scalar quantity, okay, this information can be shared. Okay, can be shared between x and y component. So which means the x component, if you find t by using x component, this t can actually be used for y component. All right, so they share same value, but that is just for time because it is a scalar quantity, right? Because it is a scalar quantity. So now let us complete this table. If you look at the questions again, the car drives straight off edge of the cliff that is 57 meter high. Now 57 meter high, if you look at the diagram, this 57 meter is located below the object. Okay, and it is a vertical displacement. So which means this is a value for y component, and it should be a negative value because it is located below object. Okay, below object. And then the investigator since of the accident notes that the point of impact is 130 meters from the base of the cliff. So from the base of the cliff, okay, it is 130 meter, and this 130 meter, as you can see in the diagram, it represents horizontal displacement, and it is located on the right hand side of the object. Therefore, is 130 meter. All right. So other than that, what is the information that we have? Goes back to the diagram. In the diagram, as you can see here, I say u equals to ux and uy equals to 0. Okay, and now what do we want to find? We want to find ux. So ux is an unknown. We just leave it at unknown. Uy is 0, so you can fill in 0. Now, do we have any other information? Yes, we have. Try to recall the assumptions that we make in projectile motion. Okay, we say object is moving. Object is moving in the moving in a projectile motion. Okay, we assume is with a negligible resistance. Okay, we neglect the air resistance, and then it's moving solely under the influence of gravity. Now, what does it mean? Okay, if you look at that two statement, so first we assume it moves solely under the influence of gravity. Okay, and then second we assume no air resistance. So which means along the x component, our object will always move with constant velocity. Okay, constant velocity. Because of why? Because no air resistance, nothing slowing it down. Okay, nothing stop it from moving, nothing changes its motion. And then gravity doesn't affect horizontal component. Therefore, your object can always move with constant velocity. But when it comes to vertical component, which is y component, Our object, well, it isn't being affected by air resistance, but it is being affected by gravitational force. Therefore, we say it is moving with constant acceleration. Okay, so remember, in a projectile motion, object is moving solely under the influence of gravity. Therefore, it only affects the y component. For x component, object move with constant velocity. Now, why is it important to know whether object is moving with constant velocity or constant acceleration? If object is moving with constant velocity, then the equations that we're going to use is just xx equals to uxt. You don't have to use that four linear equation. Okay, you don't have to use that four linear equation. The four linear equation is only for constant acceleration. So which means for y component, we are going to use this four equation. Sy equals to uyt plus 1 over 2 ayt square. Sy equals to 1 over 2 bracket uy plus vyt, and then we have vy equals to uy plus ayt, and then vy square equals to uy square plus 2ay sy. So this is for a y component where object is moving with constant acceleration. So if you notice this s equals to ut, sx equals to uxt, actually it comes from this equation, okay, where we assume acceleration is equal to 0 because there's no air resistance. Therefore, for constant velocity, we use only one equation, which is s equals to uxt. So now let us complete the table based on these two statements: constant velocity and constant acceleration. Along x component, object moving with constant velocity. So it means acceleration is 0. Ax is always equals to 0. You don't even have to look at the question. You should know how to complete the table already. And then ay, because it's moving with constant acceleration under the influence of gravity, okay, under the influence of gravity, therefore we say a is equals to negative g, which is equals to negative 9.81 ms negative 2. So for accelerations, you don't even need to you don't even need to look at the question. Okay, the value is fixed. X component and Y component, the value is fixed. So you don't have to look at the questions. By the times you complete this table, you form this table, straight away you can substitute these two value already. All right, these two value is fixed, is constant in the table. So let's see, do we have any other information? Do we have Vx? Well, Vx is equals to Ux, so they are the same. And then Vy, no, we don't have Vy, so Vy is unknown. Okay, do we need Vy? No. So what do we want to find? The question asking for velocity when it went over the cliff. So Uy is equals to 0. It means we are going to find the values for Ux. So Ux is the things that we want to calculate. All right, let's see how are we going to solve it. Now, if you look at Ux, in order to calculate Ux, the only equations that can be used is Sx equals to Ux. So Ux is equals to Sx over time. But if you look at the table, we don't have the value for time, right? But remember, time is a scalar quantity, which means you can determine time by using y component. Okay, so you need to add in an additional step, which is calculate time first before you solve the question, before you calculate Ux. So Ux equals to Sx over t. Now we want to find t. X component don't have t. Let's go to y component. So y component, do we have enough information to find t? Well, we have. We have uy, we have ay, we have sy. So we have 3 known variables and 1 unknown. So uy is equals to 0, ms negative 1. Ay is equals to negative 9.81 ms negative 2. Sy is equals to negative 57 meter. Right, so we have 3 known variables. So the condition to apply this 4 equation is you must have 3 known variables. Okay, 3 known variables. And then we want to find t. So what is the values for t? Now you have a U, A, S, T. So we are going to apply a first equation. Okay, this equation. So Sy equals to Uyt plus 1 over 2 Ayt squared. So Sy must come with negative. Without negative, 1 mark will be deducted. Okay, substitutions, you're going to get 0 mark. Okay, I'm not going to write M. Usually I write unique at the end of the solution. So negative 57 equals to 0t plus 1 over 2 negative 9.81 t squared, right? So if you calculate it correctly, okay, the time is equals to a 3.41 second, right? So time equals to 3.41 second. Now that you have time, okay, and you obtain this time from y component, okay, you obtain it from y component. So now you complete the table. So now time for y component is 3.41 second. Now time, like I told you just now, it is a scalar quantity, okay. If this 130 meter, you take a 3.41 second to arrive, then this 57 meter vertical component, it will also take 3.41 second to arrive at this position. X and Y component, you can never have different values of time. All right, then it will be in a, I would say you will be in a different world, okay, different dimensions already. So if Y component is 3.41 second, so this this X component can also use 3.41 second, right? So now we have a Sx, we have a T, therefore it is equals to 130 meter divided by 3.41 second, which is then equals to 38.1 ms negative 1. So this is the final answer. All right, and this is a typical exam question where you want to see whether you know how to use information from Y component and X component together. So the thing that is joining X and Y component is a time. Time can be used in both components. The rest cannot. All right, the rest cannot. So now I give you 2 minutes, okay, 2 minutes to write down the solution, and then if there's anything that you don't understand, you may ask. Okay, so okay, can. So 2 minutes for you to complete this question before we proceed to the next one. All right, so this one, it takes a bit longer. The time is a bit longer because it's an introduction. So far, any questions regarding projectile motions? Hello?
No, ma'am.
No, madam.
Good. Okay, make sure you understand because usually one projectile motions questions, it worth up to 7 marks. Okay, one questions like this, it can goes up to 7 marks. All right, so the marks given is start from the table, x component and y component, each one 1 marks, and then you calculate these two. Okay, you calculate you list down the value. Wait, yeah, where's my pen? All right. Okay, now sometimes the way they give marks is the first one, see whether you understand your uy is 0 or not, and then complete y components 1 mark usually, and then complete x component 1 mark, and then you substitute, you know how to use equation for y component 1 mark, t equals to 3.41 1 mark, and then u equals to sx over t, if you know how to use the equations 1 mark, final answer 1 marks. All right, so usually this one question it can goes up to 7 marks. All right, it can goes up to 7 marks. Sometimes it's a bit less, but it's still above 5. Okay, one questions like this definitely worth more than 5 marks. So make sure you understand, you know how to do it. Okay, so let us try a second question. Second question is very similar to the first one. All right, it is very similar to the first one. Okay, so questions 2. Questions 2, now you have a transport plane traveling at a constant velocity, 50 meter per second, at an altitude 300 meter directly above point X on the level of ground. So actually there's one information missing in the diagram. So this is your ground, and then this is point X. Okay, this is point X. So the diagram is a bit incomplete. All right, now the question asks you to calculate the flight times of parcel. So now this is a flight, okay, and then it drops the parcel when it's moving. Right, so in this case, what is going to happen now, because your object is going to the right hand side, the plane is going to the left hand side. Therefore, when it drops the object will begins with an initial velocity that is going to the left hand side. Okay, so this is your u, and it is equals to ux once again. All right, and again, if you look at the diagram, obviously this one belongs to horizontal projectile motion. Okay, horizontal projectile motion. So horizontal projectile motions, the important thing is the initial velocity. Okay, the important things is the initial velocity. So what happens to the initial velocity? U is always equals to ux, and uy is always equals to 0. So this is the things that you need to keep in your mind. So now let us complete the table. So like I told you just now, okay, even before I look at the questions, I should know the value for ax and ay. Ax is always 0. Ay is always 9.81, right? And then a u, as you can see here, initial velocity is a 50 meter per second, and this 50 meter per second is your ux. Therefore, I'm going to put it here, 50 meter per second. And then for uy is 0, and then a vx again, because it's constant velocity along the x component. Remember, okay, x components we have constant velocity. And then y component, we have constant acceleration. Okay, constant acceleration. And then vy, well, vy, we don't have the value. And then sx, do we have sx? No, I don't think so. And then do we have vy? Yes, because it tells us the flight is located at 300 meter above the ground. So now this one, if you look at the diagram, okay, if you look at the diagram, question tells you above point X. Sometimes students look at the question, students say, oh, above, then I should use positive. No, if you look at the diagram, 300 meter above the ground, but it is 300 meter below my object. Therefore, it should be negative 300. Okay, so you have to refer to the diagram. See where is this 300 meter. You don't judge it based on the question. Question say above point X, but X is not our object. Our object is plane. All right. So you look at the diagram, you see where is this 300 meter. Is it above the plane or below the plane? So it is below the plane, make sure to add a negative sign. Okay, so make sure to add a negative sign. So just now it's negative 9.81. And then how about time? Time, we don't have it. Why? How do I know? Because question asked me to find time, right? So let's see. Okay, let's see how are we going to find the time. If you look at the table, along x component, obviously we don't have enough information. Okay, because if you recall, what did I mention just now? If for x component, the only equations that you have is Sx equals to uxt. If you want to use x component to find time, then you need Sx. But now if you look at the table, we don't have Sx, which means questions A can only be solved by using y component. So now let's see, do we have enough informations in a y component? So we have a 1 known variable, 2 known variable, 3 known variable. We have uy, ay, sy. All right, and again, we want to find t. Therefore, questions A. Okay, questions A, we use sy equals to uyt plus 1 over 2 ayt squared. So sy is negative 300 equals to 0t plus 1 over 2 negative 9.81 t squared. Okay, and our t is equals to 7.82 seconds. So that is how we answer the questions. Okay, that is a technique in answering this question. And let's look at the number 2. Okay, questions B. Now, questions B, if you look at the question, it just mentions the velocity of impact of the parcel. It didn't mention whether it's a vertical component or a horizontal component. So in that case, what are we going to do? We are going to calculate resultant value. Okay, we are going to calculate resultant value. And since the question mentions velocity, so the term's velocity itself, it tells us it is vector. So what does it mean by vector? It means you need to find the magnitude as well as the direction. All right. So from the term's velocity itself, you can get a lot of informations. Okay, you can get a lot of informations. You can tell what types of answers that it wants. So velocity, it doesn't mention horizontal or vertical. Therefore, it is asking for resultant. And again, velocity is vector. So other than magnitude, it also wants you to find its direction. Okay, so there are two things that we need to find. So questions B, velocity of impact. So we need a Vy and Vx. So based on the table, I have Vx equals to Ux, which is equals to 50 meter per second. So now my task is to find Vy. All right, so find Vy. We have a Uy, Ay, Sy in the table. So we can use it to find Vy. So Vy equals to, Vy square equals to Uy square plus 2 Ay Sy. Okay, which is then equals to 0 plus 2 negative 9.81 and a negative 300. So without a negative sign, 1 mark will be deducted. And you actually, without negative sign, you wouldn't be able to find the final answer. Why? Because if you have a negative 9.81 and positive 300, then you will get a negative value on the right-hand side. And when you square root it, you are going to get a max error. Because if you square root a negative value, it will become an imaginary number. All right, so it cannot be calculated. Therefore, you must include the negative sign. Again, negative 300. So without negative 300, 1 mark will be deducted. So you square root the answer. So Vy is equals to plus minus 91.57 meter per second. Aha, now the question is, which values are you going to choose? Okay, which values are you going to choose? So if you look at the value, okay, if you look at this diagram, when the object reaches the ground, the directions of motion is heading towards here. Okay, toward this direction. Therefore, if you resolve it into x and y component, actually you are going to get a negative Vx and a negative Vy. All right, so this is your V. So in the table, I put it as a positive value because for horizontal component, I tend to take the directions of motion as positive direction. So in this case, what you have to take note is the directions in the diagram. Okay, the directions in the diagram. So the Vx is actually a negative value. Okay, Vx is actually a negative value. So yeah, let us add a negative in the information just now. So Us equals to negative 50. So Vy, based on the diagram, it is also a negative value. Therefore, I have Vy equals to negative 91.57 meter per second. Now that I have Vx, I have Vy, I can then proceed to resultant vector. So V resultant equals to square root Vx. Oh wait, my Vy is not 91.57. Okay, I made a mistake here. My Vy should be 76.71. Okay, 76.71. So V resultant equals to square root Vx squared plus Vy squared. Okay, which is then equals to square root negative 50 square and then plus negative 76.71 square. Okay, which is then equals to, okay, now it is equals to 91.57 ms negative 1. So this is the answer. Okay, but this is only magnitude. When it comes to vector, okay, you need to determine the direction. So this one is what we call magnitude. So magnitude is a value without negative sign. All right, so now we want to determine its direction. So theta equals to tangent negative 1 Vy over Vx. Okay, which is then equals to tangent negative 1. Vy is a negative 76.71, negative 50. So angle is equals to, what is the angles? Let me see. Angle is a 56.9 degree. Okay, 56.9 degree. So 56.9 degree, where is it? So you look at the diagram, this V resultant is located in third quadrant. Therefore, it is below negative x-axis. Okay, below negative x-axis. So that is how we solve it. So you must have both the magnitude and also the direction. Okay, this is what we call direction. Without direction, 1 mark will be deducted. Okay, 1 mark will be deducted without direction. Okay, so that is questions B. Let's look at question C. So question C, now it wants the distance from X to the points of impact. So it's asking for a horizontal distance, okay, horizontal displacement. So according to questions A, now I have time t equals to 7.82 second. Okay, 7.82 second. So for instance, if you look at the table, now we have enough information to calculate Sx. So question C, Sx equals to uxt, which is equals to 50 times 7.82, which is then equals to 391 meter. So this is the answer. All right, so we have a 3 question. So the questions that I want you to take note is question B. Right? So if questions B, it mentions a speed. Right, let's go back to questions B. Now, if the questions, it mentions calculate the speed of impact of the parcel. So speed is a scalar quantity. So it means you don't have to find the direction. Okay, so this question, I know direction is a must. Why? Because of the term's velocity. Okay, so again, I give you 2 minutes to write down the answer. Okay, I give you 2 minutes to write down answer and then write down the important notes. How do I know when to find directions? When not? When do we not don't need to find the directions? All right, whether we need to find or not to find direction. Okay. So if you have any questions, make sure to ask. If there's anything that you don't understand, okay, you can ask. If you're too shy to switch on your mic, you can just post in the message, okay, in the in-call message. Okay, so if you are done, you may proceed to the next question first.
Madam,
Yes,
why Vx is negative?
because it's going to the left.
Going to the left.
Yeah,
Oh,
if you look at the diagram, right, when the point of impact, my Vx is heading to the left.
okay.
So if you just want to calculate the informations along x component, you can ignore the sign. All right, but when you want to determine the direction, especially when you want to describe where is the v, then you need to take into consideration vx as a negative value. Okay, the directions along the horizontal component.
Oh.
Okay, so if a question just asks for magnitude, then actually with or without negative, it doesn't matter. Okay. So let us move to next question. So questions number 3. Now this question is a normal projectile motion. Okay, it is no longer horizontal projectile motion. So let's see how are we going to solve this question. So a football is kicked at an angle theta equals to 37 degree with a velocity of 20 meter per second as shown in figure below. So now if you look at the diagram, what do we have? We have u, and this u is equals to 20 meter per second. All right, and then it is located at a degree 37 above horizontal. Now the maximum height, calculate the maximum height. So when it comes to this type of questions, okay, when the questions is asking for the maximum height, or when we have a projectile motions questions like this, actually we can form two tables. All right, so question 1, it wants you to calculate maximum height. What happens at the maximum height? So this is our maximum height. This point is the maximum height. Okay, so maximum height. And then if you look at questions B, the time traveled before the football hits the ground. So it refers to point P. Point P, it goes back to the ground. So now you are looking at two different final positions. Okay, which means you can have two different tables. One table for maximum height and one table for the ground. So let us do a table for maximum height first. Okay, table for maximum height. So I have a table. So this is x component, this is y component, and then I have a u, v, a, s, t, right? U, v, a, s, t. So a for x component always equals to 0, for y component always equals to negative 9.81. And then if you look at the maximum height in the diagram, what happened at maximum height? Well, if you draw a tangent for the maximum height, the tangent line, it tells you that now your object at this point, at this maximum height, the directions of the motion is actually going to the right. So this is the directions of motion at the point maximum height. Okay, at maximum height. So why is it so important to know the directions of motion? Because it tells us what is the value for V. Okay, what is the values for V? So at maximum height, as you can see here, now my object is moving along the X component at this moment, at this point. Therefore, what can we say? We can say Vx is equal to resultant V. But then Vy is equals to 0 because there's no Y component. So it is important to have a diagram because it lets you see what happened at every single position, right? So now let us complete the table. So do we have Ux? Well, of course we do. So you look at this diagram again. Okay, let me enlarge this part. Okay, let me enlarge it. So this is what happened. So now I have a vertical component. I have a horizontal component. This is Y, this is X. And then I have U, which is equals to 20 meter per second. And the angle is 37 degrees. So now I want to resolve it. I resolve this U, okay, I obtain Ux. So this is Ux. So if I resolve the Y component, so this is my Uy. Right? So if you form a triangle here, obviously you will see that Ux is equals to U cos theta. It uses cos because angle is located beside it. And then Uy is equals to U sine theta. Therefore, we can now complete the table. So Us is U cos theta and U is equals to 20. Therefore, Ux is 20 cos 37 degrees. And Uy is 20 sine 37 degrees. So this is how we complete the table. All right, this is how we complete the table. By looking at the diagram and also the questions, try to interpret. Okay, try to extract as much information as possible from the questions. And then how about Vx? Well, we know that for X component, object is moving with constant velocity. Okay, always tells yourself X component object moving with constant velocity. So when you have Ux, it means that you have Vx as well. So Vx is 20 cos 37 degrees. And then Vy, now at maximum height, if you look at the diagram, my Vy is equals to 0. Okay, at maximum height, Vy equals to 0. Therefore, you can substitute 0 in the table. Okay, substitute 0 in the table. And then how about S? Do we have any information about S? Obviously no. Okay, we don't have the height and then we don't have the range. And then the time is also not given. Okay, now let's see how are we going to solve the question. Question is asking for maximum height. Means it is asking for Sy. All right, so questions A, maximum height. Which is a Sy is equals to unknown. So can we find Sy? Well, you can. So if you look at the table, now you have Uy, you have Vy, and then you have Ay, and you want to calculate Sy. All right, obviously you can calculate it. So Vy square equals to Uy square plus 2Ay Sy. So V is 0 equals to 20 sine 37 degrees plus 2 negative 9.81 and then Sy. All right. So next you rearrange the equation. Okay, you rearrange the equation. So you will get Sy equals to 7.39 meter. So this is the answer for questions 1. Calculate maximum height. All right, so the table is also for maximum height, as you can see here. So questions 2. Now questions 2 is about ground. Okay, it's asking for ground. What happens when it hits the ground? So it's asking for this position now. So if it's asking for this position, then you need another table. Why? Because at maximum height and at ground, okay, the object will have different V and also different S. Okay, different V and different S. So next things, I want to form a table for when the object is at ground. Right, so I'm going to repeat the table again. Okay, so X component, Y component, U, V, A, S, T, AX 0, AY negative 9.81. And then the informations for the Y component, for the initial position, U. Now, both of them, they have the same U. Okay, they start from the same point. It doesn't matter whether you want to look at the maximum height or the ground. Both of them, they start at point O. Therefore, initial velocity is the same. 20 cos 37 degree, and then 20 sine 37 degree. Vx, well, X component again, tell yourself, it's moving with constant velocity. Therefore, it is equals to 20 cos 37 degree. How about Vy? Now, we don't have any information about Vy right now. Okay, we don't have information about Vy. But what we do have is when your object, it goes back to the ground, you look at the diagram. Your O and P, both of them, they lying on the same height, same level. Okay, same level. So same level, it means your Sy is actually equal to 0. Okay, now your Sy is equal to 0, but you don't have information about Vy. Right? So a question asks you to calculate the time. Okay, now you want to calculate the time. So how to calculate the time? Let's see. X component, we don't have enough information. Okay, because recall, always tells yourself, X component, we have only one equation. So apparently, we don't have Sx. What we have is just Ux. So without Sx, you cannot find T by using X component. So obviously, these questions, we have to use Y component again. So Y component, we have U, and then we have A, and we have S. Therefore, we can solve the question. Okay, so what is the time? So V, U, S, and A, and also T. So we're going to use this equation. Sy equals to Uyt plus 1 over 2 Ayt squared. So S is 0 equals to 20 sine 37 degree T plus 1 over 2 negative 9.81 T squared. Okay, so rearrange the equations. You will get T equals to 2.45 seconds. Okay, T equals to 2.45 seconds. This is if you calculate it by using the green color table. Now, can you solve questions B by using the red color table? Yes, you can. Now, let's see. How are we going to use it? So this is our method 1. Okay, method 1, where you use green color table. Okay, green color table. And then method 2. Okay, method 2. We use a red color table. Okay, now how are we going to use a red color table then? Let's go back to the projectile motion. Now, projectile motions for the X component, we assume there's no air resistance. So why is it important to know whether it has an air resistance or not? Well, it will tell you what happened to the time, okay, to the times along X component. So if object is moving without the influence of resistance along the X component, then it's moving with a constant velocity. Constant velocity tells us that from O until point R is going to take the same amount of time as the object travel from point R to point P. Okay, so the time is the same. So which means if you calculate the time taken to reach maximum height, then you times 2, you will get the total flight time for this motion from O until point P. Okay, from O until P. You can times 2. Provided initial and final point, they are lying on the same level. Okay, they are located at the same level. So in this case, we can say the time taken from O to maximum height is equal to the time taken to travel from maximum height to P. So if you want to use the table of maximum height to calculate time, then what should you do? So let us use a y component again. So y component, we have u, v, a, we want to find t. Okay, so t equals to unknown. We have a u, v, a, so v, y equals to uy plus ayt. So v is 0 equals to 20 sine 37 degree, and then plus negative 9.81 t. Now, the method, okay, the values of times that you calculate by using second method, t is not your final answer. This t is just 1.22 seconds. All right. So the flight time from O to P is equals to 2t, which is equals to 2.44 seconds. So this is the final answer. All right. So if you use method 1 and the method 2, make sure you know what is the difference between these two methods. All right. What is the difference between these two methods? So I show you both. It is up to you which one you want to use. Okay. I won't force you to follow my method. I tell you every possible method, every possible solution. You yourself determine which one to use. Okay. So let's go to questions. Okay, now I give you some time to digest first. Okay, method 1 and method 2. So I give you 2 minutes to go through both methods. Okay, 2 minit bagi Anda untuk go through method 1, method 2. Pastikan, make sure you understand what is the difference between a red color table and green color table. Okay, so 2 minutes from now.
Madam,
Yes?
apa beza maximum height dengan ground? Tadi saya terlepas.
Maximum height dengan ground, dia punya perbezaan yang paling utama adalah dari segi Vy dengan Sy. So kalau kamu tengok table, if you look at the table, okay, if you look at the table, so for V, okay, for Vy, okay, if you look at V, now V when the object is at the maximum height, now when it is at maximum height, our Vy is always equal to 0. Okay, and then Sy, we don't have the value. We need to find it. But when the object reaches the ground, we don't have the final velocity. Okay, we don't know what is the value. But what we do know is the S. Because now it goes back to the ground, so point P is lying on the same line, same horizontal line as our O. Okay, same straight line. So we say they are located at the same level. So same level means that the vertical displacement is now equal to 0. Okay, your object goes to maximum height and then it goes back to the ground. So it goes to maximum height, max h, and then it goes back to ground. So this is actually your point O and your point P if you look at them in one-dimensional motion. So if it goes back to the original position, then we say displacement is equal to 0. Okay, S equal to 0. Because displacement is defined as the shortest distance, okay, shortest distance between initial and final position. So the shortest distance between O and P is 0. Therefore, when an object it goes back to the ground, your Sy equals to 0. All right. So for maximum height, your Sy is non-zero. It is a capital letter H, maximum height. And then when it comes to ground, it is equal to 0. So that is the main difference between these two tables. So is that clear?
Yes, thank you, madam.
Okay, cool. Okay, so any other questions before I proceed to question C? Question C, D, E is actually very simple. All right, so no? Good. Okay, if no questions means you understand, that is very good. So let us go to question C. Question C, how far away it hits the ground? So again, this one is asking for ground. How far away? It's asking for the range. So from point O until point P, what is the distance? So in this case, it means it is asking for SX. Then you can use, oops. So you can use a table for ground to solve this question. Okay. So just now we calculate and we obtain time equals to 2.45 seconds. So 2.45 seconds. And therefore, our question C, I'm just going to write it somewhere here. Question C, SX equals to UXT. Okay, so we have a UX 20 cos 37 degree. Time is a 2.45. Therefore, SX is equals to 39.1 meter. So question C is very simple. Once you know what is the difference between maximum height and ground. Questions D, what does it mean by velocity vector? Now you have a new term, velocity vector, acceleration vector. Wow, it just wants to trick you. Okay, actually, it's asking for Vx and Vy. Okay, and then this one is AX and AY. So at maximum height, Vx is equals to your V. Okay, Vx is equals to your V. Therefore, the value is 15.97. So Vx equals to 20 cos 37 degree, which is then equals to 15.97. Okay, 15.97 ms negative 1. And then Vy, now Vy, like I showed you just now, it is equals to 0. So straight away, you just write 0. Ax and Ay, you don't even have to calculate. We already filled it in the table so many times. So Ax 0, ms negative 2, Ay negative 9.81, ms negative 2. Done. That's it. So questions D, actually, you know how to do it. Okay, it's just that you might not understand what does it mean by velocity vector, what does it mean by acceleration vector. Okay, so dia tricky punya part dekat sini. Dia guna perkataan velocity vector. But actually, the questions is asking for Vx and Vy. Horizontal component and vertical component at a certain position. All right. So, okay, 1 minute for you to tidy up the questions. Okay, for you to tidy up the solutions. Then we will proceed to questions 4. So, if you have any questions, you may ask. Okay, 1 minit untuk kamu lengkapkan semua tadi. And then kita akan buat soalan 4. So, soalan 4 kalau kamu sudah buat, okay, kalau kamu sudah siap soalan 3, then you can try first. Okay, while waiting for the rest. So you may try first, draw a diagram.
Madam,
Yes?
why U and V is always the same for X component?
Because object is moving with constant velocity, because we assume there's no air resistance. So if there's no air resistance and also no force that affect the motions of the object along horizontal component, then Vx and Ux is always the same. Unless you have external force acting on it along X component. Whereas for Y component, object changes its velocity because of gravitational force. So gravitational force is acting as an external force that affect the motions along vertical line. But we don't have anything that will affect the motions along horizontal line. Therefore, Vx always equals to Ux.
Okay.
Right? Let's see. Any other questions? No? Very good. All right. So now questions 4. Questions 4. A ball is thrown from a point. Now this is a tricky question. So a ball is thrown from a point that is 1 meter above the ground. The initial velocity, 20 meter per second, at an angle 40 degree above horizontal. So how are we going to sketch the diagram? So you need a ground, and then you have a building. This building is 1 meter tall, and this is the positions of your object. Okay, this is the positions of your object. And then according to the question, this object will move at an initial velocity, which is 20 meter per second, at an angle 40 degree above horizontal. So how are you going to sketch it? So you're going to put a dotted line, okay, to represent the horizontal component. And then this is the directions of your initial velocity. So u equals to 20 meter per second. And then this is the angle. Okay, angle is equals to 40 degree. So that is the meanings of the question. So you need to know how to sketch the diagram. All right. The main reasons why I asked you to sketch the diagram is because if you look at the questions again, questions A asks you to calculate the maximum height, not just the maximum height, read until the end of the questions, the maximum height of the ball above the ground. So you need to take into consideration this 1 meter, because this 1 meter is represent the distance from ground to the object. All right. Whereas when you calculate the maximum height, the things that you're calculating, okay, let's say this is your projectile motion. Okay, so this is your projectile motion. Okay, no, I don't want this. Okay, now you throw something at an angle 40 degree. So what happened is that I undo too many times. So this is an angle theta equals to 40 degree. So what happens here is that now you want the height from the ground above the ground. So your above is 1 meter. So this is the shape of our projectile motion. Okay, let's say this is the shape of projectile motion. So maximum height that you calculate by using the table that we learned before is just the distance from this horizontal dotted line. Okay, this horizontal dotted line until maximum height. This is a capital letter H. So that is the things that we are going to calculate. All right, so we are not going to calculate the information from the ground because our object starts from here. Okay, this is our H equals to 0, let's say. Okay, this is a reference line. So the information that we calculate by using the projectile motions equations, the method is actually just the H from this dotted line until the maximum height of the object. So now let's form a table. Okay, let's form a table. So again, I have X component, I have Y component, I have U, V, A, S, T. So AX is 0, AY is negative 9.81. All right, so this two thing is because of accelerations, okay, gravitational accelerations. Okay, so now UX, do we have it? Yes, we do. Okay, because UX we know is equals to U cos theta. So 20 cos 40 degree, and here would be 20 sine 40 degree. Vx 20 again, cos 40 degree. And then Vy, we don't have the value, or do we have? Yes, because it's maximum height. So remember, at maximum height, the motions of the object is going to the right. So V equals to Vx, Vy equals to 0. So it is equals to 0. Okay, so Sx, we don't have it. Sy, we also don't have it. Sy is actually the H. Okay, so it has nothing to do with this 1 meter. This 1 meter is for you to calculate the final answer, the maximum height above the ground. So this is our ground. Right? So that 1 meter has nothing to do with the table. Remember, that is very important. because students always get the wrong idea. They substitute this 1 meter into the table. No, it has nothing to do with the table. Projectile motions only happens along this horizontal, above this horizontal line. Okay, above this horizontal line. So projectile motion happens above it. So now let's see how are we going to calculate capital letter H. Do we have enough information? Obviously, yes, we do. We have a uy, vy, ay, 3 known variable with an unknown H. Therefore, I'm going to use equation vy square equals to uy square plus 2ay sy. Vy 0, sy 20 sine 40 degrees square plus 2 negative 9.81 H. And my H is equals to 8.43 meter. Then don't forget, this is not the final answer yet. Okay, and this is a very common since careless mistake in the exam. Okay, students tend to get too excited when they got the answer H equals to 8.43. They forgot they haven't answered the questions yet. All right, the question is asking for the height from the ground. So maximum height, okay, you need to write it in statement. So maximum height of the ball above the ground is then equals to 8.43 meter plus 1 meter, which is equals to 9.43 meter. So this is your final answer. Okay, if you forgot to calculate this maximum height above the ground, 1 mark will be deducted. Okay, 1 markah akan ditolak kalau kamu terlupa kira height of the ball above the ground. Dan inilah part yang biasanya pelajar lupa. Okay, sebab mereka excited. Mereka ingat, oh hebatnya saya sudah dapat H ini. Tapi dia belum jawab soalan sebenarnya. Okay, so that is your questions A. Yes?
Kalau yang plus 1 tu, dia buat yang masa first kali tak apa ke?
Maksud kamu first kali kamu buat H plus 1?
Maksudnya lepas dah dapat apa tu H tu tambah terus 1.
Tak boleh. Mana boleh terus H equals 8.43 meter and then plus 1. That is wrong in terms of mathematics.
Okay.
Okay, your mathematics tells you.
Yang panjang ni baru tambah 1.
Sebab yang ini H sama dengan 8.43 is coming from the equations ini. Kamu tak boleh tiba-tiba tambah 1 meter di belakang. Ini salah dari segi matematik.
Oh, okay. Thank you, madam.
Okay. Alright, now question B. Calculate the speed. Now you look at this question. This question is asking for speed. So speed is a scalar quantity. So in this case, you don't need direction. Okay, no need direction. So which means it's just the magnitude. Okay, magnitude without direction. So calculate the speed of the ball at the highest point in the trajectory. So highest point at the trajectory means that it's asking for the speed at maximum height. Okay, speed at maximum height. So speed at maximum height, the things that we know. Okay, questions B. So at maximum height, we know that V is equals to Vx. Therefore, V is equals to 20 cos 40 degree, which is then equals to 15.32 ms negative 1. That's it. Okay, that's it. It's very simple. So in case you forgot, okay, you can use this concept. You want to use Vx and Vy to calculate it, also can go ahead. Okay, but remember, for these questions, you don't need direction. Okay, don't need direction because the question is asking for speed. Speed is a scalar quantity. Scalar quantity means you just need the magnitude without direction. Okay, so this answer, I give you again 2 minutes to write it down before we proceed to final questions. So if you are done, you can try final question first. It's very similar to questions 4 actually. Okay, so this is a very simple questions. Now let's look at the questions 5. Questions 5 very similar to questions 4 if you look at the questions. So an apple is thrown at an angle 30 degrees above horizontal from the top of a building that is 20 meter high. Okay, top of a building. So now your object again is not start from ground. So the initial speed is 40 meter per second. So the diagram is exactly same as the previous question. Now you have a building. This is the ground. This building is a 20 meter high. This is the object, okay, which is your apple. And then it is 30 degree above horizontal line. And then your U is equals to 40 meter per second. That is the question. Okay, that is a diagram that I sketched based on the questions given. So calculate the time taken for the apple to strike the ground. So now your object is moving. Okay, it's moving like this. So it strikes the ground. So you want the informations at ground now. Okay, you want the informations at ground now. So let us do a table as usual. Okay, a table, I'm going to put it here. So this is the table. Okay, and then this is X component, this is Y component, U, V, A, S, T. So A again, 0, negative 9.81. So according to the questions, I have initial velocity equals to 40 meter per second above, 30 degree above the horizontal. So 40 cos 30 degree and 40 sine 30 degree. And then Vx is the same, 40 cos 30 degree, but Vy we don't know. Okay, so if you don't know, then you leave it blank. Now, how about S? This question is asks you to calculate the time taken for the apple to strike the ground. So it means ground is your final position. Okay, so this is your final position, and this is your initial position. So when it comes to displacement, we want to look at the distance between initial and final position. All right, so the shortest distance between initial and final position is 20 meter. And you look at the final position. This final position is located above initial or below initial. It's below. So in this case, we have a SY which is equals to negative 20 meter. Okay, so you have to look at where is your final position based on the questions given. So in these questions, the final position given is the ground. So in this case, we have SY equals to negative 20 because final position is located 20 meter below your initial height, okay, initial level. Sx, we don't have it, and then time, we also don't have it. So that is our table. All right, that is our table. So questions A asks you to calculate the time taken for the apple to strike the ground. So you want to calculate time. Okay, we don't have time. So let's see, do we have enough information along X component? Again, we don't have because we don't have Sx. So without Sx, we cannot calculate time. So it means once again, we want to use a Y component. So Y component, we have Uy, we have Ay, we have Sy. Then we can solve it. So Sy equals to Uyt plus 1 over 2 Ayt squared. Sy negative 20 equals to Uy, which is 40 sine 30 degree t plus 1 over 2 negative 9.81 t squared. Okay, then rearrange the equations. You will get t equals to 4.91 second. Okay, your t is equal to 4.91 second. And then questions B, the distance from the foot of building. So the distance from the foot of building, it is asking for this, the distance from foot of building until the point of impact. So it refers to Sx. All right, it refers to Sx. So B, now you have a t equals to 4.91. You can put it in the table. So 4.91, and then you have Ux. Therefore, we can calculate Sx. Sx equals to Uxt, which is equals to 40 cos 30 degree times 4.91. And therefore, it is equals to 170 meter. That is your question B. Question C. Calculate the maximum height. So it goes back to the questions that we did in the previous questions. Okay, the maximum height from the ground. Therefore, it is asking for this h again. So if it is asking for this h, it means you cannot use sy equals to negative 20 anymore. All right. So this one, maximum height, the table is slightly different again. Okay, so this is the table for ground. So if you don't want to form a new table, it's fine. But if you want to form a table, I will show you the table so that you see what is the difference between maximum height and ground. Okay, so now I'm going to draw a table for maximum height. Just now it's a table for ground. So table for maximum height. Okay, so ini kamu nak buat tak nak buat, it's up to you. I will show you so that you can see the difference. Okay, so that you can see the difference. So this is X, this is Y, U, V, A, S, T. So the information that we have again is 0, negative 9.81. Initial, well, both of them, they start from the same initial position. So 40 cos 30 degree, no issue. 40 cos assign 30 degree. And then this one is a 40 cos because it's constant velocity. Now, when it comes to maximum height, our Vy is always 0. Okay, so this is the first difference between ground and maximum height. All right, and then the next information that is different. Now we want to find maximum height, which is this h. So this is the second difference in these two tables. So just now we know final position is located 20 meters below original position, but now we want maximum height, so we don't have the value. Okay, we don't have the value, and we also don't have the time. Now, can you use a 4.91 divided by 2? Cannot. All right, because this 4.91 is the time taken from initial until final. And then for times 2 case is from initial until the same height level. Then the time from here would be same as the time from here. So you cannot say now I want to calculate information at maximum height. I use 4.91 divided by 2. Cannot. All right, cannot. If you divide by 2, then you're going to get the wrong time for maximum height. So the time from initial position until maximum height and from maximum height until this point X, they are the same. Okay, but not until the ground anymore. Alright, ini beza dia. Kamu kena tahu bila kamu boleh darab 2, bila tak boleh darab 2. Okay, dia cuma boleh darab 2 kalau initial dan final dia jatuh pada horizontal line yang sama. Untuk case ini, initial dan final, obviously they are not lying on the same horizontal line. Therefore, you cannot times 2 or divide by 2 the time. Okay, so which mean we don't have the time at maximum height. All right, this is unknown. This is unknown. So we have no way to find it. Okay, unless we use equations, the linear motion equations. So question asking for maximum height. So if you look at the table, now you want to find h, which belongs to a vertical component. Therefore, we have a u, v, a. So we want to find s. So again, it's a v square equals to u square, vy, uy plus 2ay, sy. Okay, 2ay, sy. So v is 0 equals to 40 sine 30 degree plus 2 negative 9.81, and then sy is a, okay, I'm just going to write h. Okay, h. So your h is equals to 20.39 meter. Okay, 20.39 meter. But that is just for h. Now the question is asking for from the ground. Okay, so from the ground, once again, you need to rewrite it. Okay, you need to write one more sentence. So maximum height from ground is equals to 20.39 meter plus 20 meter, the height of the building, which is 40.39 meter. So this is the final answer. Alright, so this is a fine answer. Okay, so that's it. That marks the end of today's class, right? So you write it down. If you have any questions, you may ask. Okay, if no questions, then you may leave the class now. So this is the end of today's class. All right, because we managed to finish it, so we don't have to drag until 4 p.m.
Madam,
Yes?
link kehadiran kat mana?
Kehadiran tak payah sebab memang saya dah tengah track kehadiran kamu.
Okay.
Okay, kamu masuk kelas berapa minit pun saya tahu.